When we use data to make decisions, we grab a sample from our population. So Chapter 8 is all about finding the right sample size. I don't always have all the resources to have a huge sample size. And also confidence intervals. So basically when I have a sample, I need to add and subtract some margin of error to it. It's not perfect because it's not from the population. So there's actually kind of an error built into it. So we can say, for example, I can be 95% confident the proportion of defective parts coming off this assembly line is, between 6 and 10, for example. So we'll see some examples, but we'll start with how do I know how big of a sample size I actually need for a certain level of error? So how much error am I willing to have? Okay, so of course in most cases we would want a large sample size, as big as possible. But if I'm short on resources, time, I want to know the smallest sample size needed possibly. So I choose a certain amount of error that I'm willing to have. So let's say, I want to be within 5%, or I want to be within $2 of the actual population mean or actual population proportion. Okay, so for example, I might be okay with a 5% error if I'm talking about percent of defective products. Okay, so sample size determination can tell us how big of a sample we need with a given level of error. So in Megastat, if you go to confidence intervals and sample size, we'll start with sample size. And then you enter the error and any estimate of the standard deviation that you have. So we're starting with a mean problem. You'll see sample size mean. So if we wanted to know the average amount spent in our store, that's a mean. So I want to get how big of a sample size do I need to get in order to find the average amount. And the standard deviation may come from a previous sample, a pretest. So you basically put in your error. So if I am talking about amount spent, maybe, I want to be within $5 of the true population mean. So maybe I'll put $5 as my error. Standard deviation, again, could come from a pretest or a previous data. So enter whatever standard deviation you're given in the problem. And then confidence level we'll discuss a little bit more in the rest of Chapter 8. But basically, the higher the confidence level, the less likely for a type 1 error, which we'll talk about later. So basically, higher confidence, less error. So the typical ones are 90%, 95, and 99. Here's the equation that luckily Megastat does for us. But you can kind of see what goes into it. That z-score is basically where the confidence comes in, and the standard deviation, any estimate that you have in the problem, like I mentioned, and then the error that you're willing to have. That squared gives you the sample size you should have. Okay, so always round up since you're talking about number of observations, so you won't have, 0.2 observation or half of an observation or person. So you might as well just round up because the bigger the sample, the better. Okay, so let's look at a typical problem. Last year, a study showed that the average ATM cash withdrawal took 65 seconds with a standard deviation of 10 seconds. So notice I'm given some previous data. That standard deviation is going to help me. As you saw in Megastat, I need an estimate of the standard deviation. The study is to be repeated this year. How large of a sample do I need? With 99% confidence. Again, the confidence is typically 90, 95, 99, and the higher the confidence, the less probability of a type 1 error, which we'll talk about later. But again, the typical ones are 90, 95, and 99. And I'm willing to have an error of 5 seconds here. Okay, so those are the possible answers. Let's switch over to Megastat.